Alright everyone, this is where we left off. We left off on problem 131, letter D. So we were finishing up this problem, and the only thing we needed to do was name the excluded values. So as mentioned before, we need to look at our expression before we start building our big ones, or as we like to call it, canceling terms. So if we notice 2, 0, and that's it. So 2 and 0 are our excluded values. Those are the values that if we plug them into x, they give us 0 on the denominator. Alright, so moving on, we'll go to the back side. So on the back side, we want to factor the expressions below. When you guys have a x squared term and the next term, you're pretty much looking to see what you can factor from each of those. So this is a little bit simpler than when you have a polynomial like this one, where you have the x squared term, the x term, and the term by itself, more so like this one. So for this one, all we need to do is look at what we can factor. So in this case, we can factor an x and a 3 from each of these. So we're going to be left with 3x times x plus 3. And that's it for that one. For this one, this is a difference of squares. So anytime that you have a difference of squares, you're going to end up with something plus something times that same thing minus the same thing. So in this case, 4x plus 5y times 4x minus 5y. So notice that we have 4x and 5y in both cases, but in this one it's plus and then this one is minus. So difference of squares is easy in that sense. You always have a situation like this. For this one, we want to look at a and b as pretty much, I guess, variables that are going to multiply to give you a sort of like a polynomial, like x squared, x, and a constant. So for this one, if we look for what we can factor this to, we can draw a generic rectangle or an area model. So let's look at this one. This one we have, first let's see if we can factor anything out from this. So I noticed that I can factor out 3 in each case and a. So I can factor out 3 and a from each of these terms. So I'm going to pull out a 3 and an a, and I'm going to be left with 2b squared plus 5b minus 7. So notice that if I were to distribute 3a, I would get the same thing again. So now that I have this, I can factor this polynomial inside the parentheses. I'm going to use, I can use the diamond problem. So negative 7 times 2 gives me negative 14. Whenever you have a coefficient in front of your squared term, you need to multiply it times a constant. And then I have 5. So now I need to look and check what two numbers give me negative 14 and 5 when I add them. So that's 7 and negative 2. So the next thing is, because I have a coefficient of 2, I need to go to the area model. The only time when you don't have to go to the area model after the diamond problem is when you have a coefficient of 1. But anything other than that, you're going to have to use the area model after you find these two numbers. So now I have 2b squared minus 7 plus minus 2 and 7x, or I should say b in this case. So notice that I'm using the two numbers that I found here to write my b terms, and now I can find my dimensions. So for this one, it's going to be let's say 2b, this is going to be b, this is going to be plus 7 and minus 1. So now I see that this works out. Everything inside is given by these two dimensions. So I'm going to get 2b plus 7 and b minus 1, and then 3a. So when I factor this polynomial completely, it ends up being 3a times 2b plus 7 times b minus 1. And this is my final answer right here. For this one, it's a little simpler, so we just do the diamond problem. Negative 24, 5. The two numbers that give me this are 8 and negative 3. So my factored polynomial is going to be x minus 3 times x plus 8. Notice that because I have a coefficient of 1, I don't have to do the generic rectangle. Alright, moving on to the next problem. For this one, this is called a composition of functions. So this is telling me that we are going to calculate f of g of 2. So first I need to do g of 2. So I need to plug in 2 into this function. And when I get my answer, I plug it into the f of x function. So this is going to be, well, let me try this one first. So g of 2 is going to be 2 times 2 plus 6, which is equal to 10. And now I'm going to get 10 and plug it into f of x. So now it's going to be f of 10 equals 4 times 10 squared, which is going to be 100 times 4, so it's 400. So f of g of 2 is equal to 400. The only thing I did is I did it in 2 steps, but you can do it in 1 step if you want it. Alright, this one is going to be now we're going to plug in 4 into the f of x function first, and then whatever answer we get, we plug it into the g of x. So for this one, we have f of 4 is equal to 4 times 4 squared, which is equal to 16 times 4, which is going to be 64. So 16 times 2 is 32, and then times another 2 is 64. And now we need to plug that into g, the function g of x. So it's going to be g of 64, which is going to be 2 times 64 plus 6, which is going to equal 2 times 64, that's 128, plus 6, that's 130, 134. So that's my final answer right here. So if you notice, we do get 2 different answers. Well, we plugged in a different number to begin with, but that's pretty much what this is asking you to do. Alright, moving on to the next problem. To multiply these, let's go ahead and use an area model to help us. So for this one, remember that x minus 4 squared is really the same thing as x minus 4 times x minus 4. And I would go ahead and put the minus in front of the 4 like this, because otherwise you might forget if you put it in the middle between them. So there's going to be x squared minus 4x minus 4x plus 16. So my overall polynomial is going to be x squared minus 8x plus 16. And that's it. For this one, first let's go ahead and multiply the 2 binomials here, and then we'll multiply times 3, negative 3 at the end. But if you want, you can multiply negative 3 times the first binomial and then use an area model. So either way is fine. I'm going to go ahead and multiply these two first, and then I'll multiply times negative 3 at the end. So this is going to be x plus 2, 2x minus 1. I'm going to get 2x squared, negative x, 4x, negative 2. So I'm going to get negative 3 times 2x squared plus 3x minus 2. And my final answer, I just need to distribute the negative 3, so I'm going to get negative 6x squared minus 9x plus 6. And this is my final answer right here. Negative 6x squared minus 9x plus 6. For the next one, you can use an area model as well. It's just going to be a 3 by 2. Notice that right here we have 3 terms, and in this one 2 terms. So we can draw something like this. 1, 2, 3. So x plus 2, and then we have x squared minus 4x plus 3, and we're going to get x cubed minus 4x squared, and then right here we're going to get 3x, here we're going to get 2x squared, negative 8x, and then here we're going to get 6. So when I combine all this together, I get 8x cubed, negative 2x squared, negative 5x plus 6. And that's my final answer. Notice that I'm just combining all the like terms right here, so I get a result of negative 5x and negative 2x and so forth. Alright, and then moving on to our next problem. For this one, we're going to go ahead and split this up into two problems. So it's going to be x plus 2 equals 6, or x plus 2 equals negative 6. And when we solve, we get negative 8 and 4. So these tell me my boundary points. So I know that my boundary points are at 4, and we have a open inequality, so it's going to be open circles or open points, and negative 8. And if I test the value in between these two, I'm going to test 0. So 0 plus 2 is 2. Absolute value of 2 is 2. So 2 is less than 6, which is true. So that tells me that the values in between are going to be the values that work for this inequality. And now my solution has to be written like this. X has to be greater than negative 8, but less than 4. Alright, so that's my solution right here. And the last problem, it says graph the system. Right here, this 2 belongs to this inequality down here, just so you don't get confused. So this graph is going to be a parabola shifted 1 unit to the left. So it's going to look like this. Alright, and I have a less than or equal to, so then that means that it's going to be a solid line. My other one is going to be dashed, and it's going to be at negative 2 and 2 over 3. So it's going to look like this. And then I'm going to shade. So for this one I shade above, for the other one I shade below. So my final answer is going to be this. Alright, so hopefully this helped. Good luck tomorrow, and I'll see you then.